Okay guys, this video is a part 2 of how to easily set up SSL on your website, your API, without having to install a SSL certificate. There was some confusion on my last video. I think if you're trying to set this up and you haven't seen either video, go back, watch that first video, give that a shot. If you have an issue with that video, come back to this video and we're going to go into more detail here. We're going to walk through the whole process step by step. I'm actually going to set up a website this time. I'm actually going to put the DNS records in place to point the domain registrar to the cloud service and go through that entire step. So hopefully this will eliminate any ambiguity that might have come up in the last video. So let's get right into it. I think before we dive into the actual technical steps to put this in place, I want to go over just a high level of how all these different moving pieces interact. Because if you don't have an understanding of how all these pieces play in together, then when you're trying to troubleshoot this sort of thing, it's not going to make a whole lot of sense to you. So let's actually first go through what are each of the endpoints in this system and how do they talk to each other, how do they connect, and let's go into that detail here. So again, what are we trying to do? We're trying to set up a website that supports SSL, and so there's a bunch of different pieces to that, and I will just draw that out here to make that very clear. So let's start with the client. So the client is any machine that actually wants to access the website data. So it could be your desktop computer, it could be your iPhone, or it could even be an IoT device. These are all clients. For the sake of this example here, let's say it's your iPhone. So say you're on your iPhone and maybe you pull up your browser. So you pull up Chrome. And you want to make a request to a particular website. So we want to make a request to google.com. So what actually happens when I type the domain name www.google.com into Chrome, well, there is what we call a local cached DNS on your device, which basically is a mapping of domain names to likely IP addresses, and this is based on websites that you visited, and I think also like common websites. And it's a dynamic document. It changes over time, and that's one way that your device is able to connect the domain name to an actual IP address. That IP address is called the origin IP. It's the remote server that we want to actually retrieve some content from. So you have local DNS that may know what IP address to proxy that request to. But you also have something called global or cloud DNS. And this is maintained by a bunch of different companies and different services. And again, what does global cloud DNS do is it knows how to point a domain name to an actual IP address. The reason we use domain names is because they're phonetically or mnemonic devices to easily target a particular server. So it's just an ease of use sort of thing, but there needs to be that mapping stored somewhere. And so there's also a global cloud DNS. And so when I issue the request for www.google.com, it may go to, if there's no local DNS in place, it may go to a cloud DNS. And the cloud DNS might say, okay, you want www.google.com. Well, this maps to to a set of name servers. So the way you send a domain to an origin is usually through name servers. That's just the most common way. You can also do it through A records or C names, so alias names or canonical names. But for the websites that you'd be setting up, you're just going to use name servers. So the domain registrar that has this google.com registered points to a set of name servers. There's usually 3, but there could be 4, there could be 1. The name servers are the location of the hosting provider. So the name servers could be put in place by DigitalOcean or by AWS or GCP, whoever's hosting the actual web service, the origin web service. And so we might say here, okay, we want to proxy this to the Google name servers, and I forget what those are, but it might be something like cloud.google 1.ns or something like that. And once that request hits the Google name servers, the name servers will know where to proxy that request, because when you set up a domain on the host environment, you've authenticated that domain, so it knows that you are the owner, and when those requests come in, it's able to handle those requests. But you have to set up that mapping, because you need to take this name server and actually point it to something, right? It could be your website, it could be your virtual machine. You need to point it to something. And so this is done for the Google setup. This is done using load balancers. So we would set up a load balancer that has these records in place, has our domain set up in these records, and then it gives you the opportunity to point it somewhere. So when that request comes in, it gives you the opportunity to point it somewhere. And what we're going to do is we're going to point it to our VM. Our VM is just a Linux box that has our Nginx web server software running. It will respond to 127.0.0.1 or the local host. So anyone who makes a request to that web server will get a response. And so let me just draw this out here. So we will have the load balancer here. Now the load balancer, there's all sorts of awesome cool things you can do with the load balancer. You can put algorithms in place to distribute load over multiple instance groups and that sort of thing, and there's different algorithms like round robin or CPU based algorithms and things like that. And but we don't need to get into that complexity. But what we're going to leverage the load balancer for, the GCP load balancer, is we're going to have the load balancer take care of our SSL handling, because from the client's perspective, the client only is able to understand where the request is getting proxied to up until the load balancer, because this is your front end IP address. So if I was on my my laptop here and I did a command called dig, D-I-G space, and then I threw the domain in there, it will show me all this chain of proxying, but it will only show me up till the front end IP, because the front end IP is the last public access point for this particular request. And so it's the front end IP that needs to have our SSL. And that's where we're going to set up. We're going to say Google enabled SSL, and it's just going to take care of it. And then what we're going to do is we still need to handle this request, because we've handled the domain, we've pointed it to GCP, and GCP points it to our load balancer. But okay, then what happens after the load balancer? Well, the answer is we need to proxy it to our virtual machine. So in GCP, we have a virtual machine, a single machine, that's running Nginx. think there's an I in there. Nginx is like Apache or Node. It's a server software, and this is actually going to return our HTML website. But what's really cool about this is in the past, you'd have to set up SSL on your server. So you'd have to add the certificate into the Nginx config or the apache.htaccess file, or even Node. You have to set up the SSL. What we're going to do, which is really slick, is we're going to do SSL termination at the front-end IP, at the load balancer. Because again, this is the last public endpoint, meaning everything else is private, everything else is in our internal network. So when the request gets here, we terminate SSL, and we proxy to Nginx using HTTP. And that just makes our life a whole lot easier. And also is actually more performant. Anytime you do an SSL handshake, yeah, there's time associated with that on the device, on the server, and so you want to, potentially you want to limit that. Is there a security concern? In this case, no. I mean, it's an internal network, so no one should have access to that. But if someone did have access to it, could they intercept the HTTP and read it in plain text? Sure. So you do want to think about that. But I mean, as far as agility goes, this is the ideal setup here. So the request comes to the load balancer. The load balancer is just going to proxy to our Nginx. Our Nginx is represented by an internal IP. And we just say when the request comes in, let's proxy it to, we actually don't even point it to an IP, we point it to a VM group. In GCP, they're called VM groups. They expect you to have multiple servers. You can have a VM group with a single server, which is what we're going to do. But you just point it to your VM group by name, and then the VM group will pick a server, and if there's only one, it'll pick this server here, and this will return our website. So here's one thing that trips people up is when you're setting this up, it's not all instant. The reason it's not instant is because when we set up our DNS records with our domain registrar, whether it be GoDaddy or Namecheap or whatever it is, there's something called DNS propagation, and it's related to TTL, time to live. When you set these up, you can put in place a TTL. Could be 60 seconds, could be 5 minutes, could be 24 hours. So you put these rules in place and they have to propagate out to the clients, right? First off, the cloud DNS has to update, but then the device's local DNS has to update. So sometimes people make these changes, they don't see their website working immediately and they think something's wrong. Well, it's just propagation happening. One thing you could do to try to expedite the process is on your desktop or your laptop, you can run Flush DNS. Flush DNS should take care of this issue and allow you to validate that your website is working properly. Yeah, so I think that's basically all of the different points here, but I guess my point is like there's a number of different endpoints that this request gets proxied to, and with more popular websites like large-scale websites, there's even more devices in here. You usually have another layer of the complexity called a CDN, which is Content Delivery Network. So actually, usually what happens is the domain registrar can point to a CDN like Akamai or Cloudflare, and the idea there is if I'm in China and I request google.com, my request better not get proxied through Australia or the US or something like that. It should be geographically efficient, and that's typically what CDNs do. CDNs also offer caching at the edge, they call it. So, if I have my website and I'm in Boston, my local server or the closest server in proximity to me might actually cache like an image or cache the actual website, so it doesn't even have to hit the origin server, and then that cache just gets updated at some interval. So there's usually a lot more complexity involved here, but for our setup, this is going to be how it works. And just the benefit of this is we don't have to buy an SSL certificate. We don't have to worry about it expiring. We just enable it on the load balancer, and Google takes care of it, which is awesome. Just saves us a bunch of time. We can stop using it whenever we want, and we can just not have to worry about that headache. We don't have to set it up on the server level. So tons of advantages to that. Anyways, just want to give you a quick background on what's actually going on here that we're creating, and this is what's going on here. So, all right, that's all I have on that front. Let's dive right into it. Okay, so let's get this party started. So step one is let's create a website. We're going to do so using GCP. This whole example is how to set up SSL easily using GCP. So the way we do that is we go over to Compute Engine, we go over to VM Instances, and we go Create Instance. This instance could be an API, could be Node.js, Flask, Tomcat, Apache, Nginx, whatever other server software you're familiar with, could be any of those. So let's call this Demo Website. And let's keep it pretty lean here. So I'm just going to enable traffic on both HTTP, HTTPS, and yeah, I think this is all good. It's going to give us a Linux server, but it doesn't really matter here. So let's just go ahead and create this. And that's just going to take a second to spin up. Okay, looks like it's ready to go. Note how it gives us an external IP. So if we want to see, what the server is responding to localhost with, we can see that by just opening this up in a tab here, and you can see it's going to put it in HTTPS. Let's put it in HTTP, and nothing's coming back. Why? Because we have nothing set up. Let's go set something up. I'm going to SSH right into it. So what I like to do is I like to run sudo su dash. See how it says Timothy? It has my name there. Well, if I do sudo su dash, it elevates me to root. And that's just better because root can do everything, and so I just don't want to have to deal with anything. So the first thing we do is this is a new Linux instance. We're going to run apt-get update. This will update all the packages. And we're going to use packages to set up our server. We're going to use the Nginx package. So I should be able to do apt, I think it's apt-get install Nginx. Apt-get, I forget what it is. All right, apt-get install Nginx. Do you want to continue? Sure do. Okay, so in theory, we just installed Nginx. Nginx is server software. High performance load balancer web service software. I'm actually a fan of Nginx. I like the syntax for the server configuration as opposed to like Apache. It's also very good for if you need like a reverse proxy. It's pretty good with that. Oh look, our website just rendered. Why did it render? Because we downloaded Nginx. And when we downloaded Nginx, one of the things it does is it actually stands up your server. So like if I do curl localhost, I get my HTML page. And this is the same thing we're seeing over here. It just knows to respond to localhost. You could put configs in to respond to like a particular path. We're not going to get into any of that. But just to prove that this is our website and all that, let's make a small edit. So if I go into var www, this is usually where Nginx puts all its HTML. Yeah, there's this index file. So I'm just going to do, well, I need a text editor. So I'm going to go back to apt-get install, and I like Vim. So I installed Vim, and then I'm going to do Vim index. Now I can edit this. So let me just go into our H1 tag here, and I'm going to say SSL tutorial, and I will save that and exit. And now when I refresh my page, so this is my HTML page. There could be, you know, a whole hierarchy of static pages or whatever. The point is we have a server set up, and you can see it's not secure because we haven't gotten that far. But we have our server set up, it responds, all looks good. So let's move on to setting up SSL for this mock server here. Okay, so we're going to create our instance group. So let's go over to instance groups, create instance group. All right, we want unmanaged instance group. If we do managed, you have to create this template, and then every VM has to abide by that template. We're going to do unmanaged. I'm going to call it SSL tutorial instance group, and we're going to add our VM to it. So demo website, and we're going to do create. So now we can point our load balancer to it. So let's go to network services. All right, so now let's set up the load balancer. SSL tutorial load balancer. All right, now we have to set up all the various aspects of it. Backend configuration. So when the request comes in, hits the load balancer, Google needs to know what to do with it. Well, we point it to our VM group, our instance group. And it's pretty easy here. We just go, we do have to create a backend service. So create backend service. We're going to call this SSL tutorial backend service. And then we just point it to our instance group here, SSL tutorial instance group. Pretty easy. Now we could keep HTTPS, but as I mentioned, we want to terminate HTTPS once it gets to the load balancer. So when the request comes into the load balancer, it's going to terminate SSL, proxy it to our Nginx server, which is more performant and easier to manage. And we should be good to go. I don't think we need to adjust any of these other aspects. Oh, I'm sorry. We do need to set up a health check. A health check is just a route that responds that Google will call intermittently to determine that the backend service is up and running. So we can keep this really, really basic. So like, let's create another health check. Let's call it SSL tutorial health check. So like, you might want a designated route like /heartbeat or something. But what we could also do is just ping the home page. So we're going to do an HTTP health check. The path is just going to be /, and then we select the time and the interval here. So it'd be like a machine making a curl request to this every, whatever it is, 5 seconds or something. And it just wants to make sure that it gets a response back, and it just runs that. You could modify the logic so like it needs a particular response code or needs a particular response body, all that stuff. We don't need to get that complicated. So that's our health check. Now, if it doesn't respond, if it runs curl and it gets, some sort of 404 or something, well, in this case, that would be okay. But if it didn't get a response, then the load balancer will flag it as unhealthy, and it will actually it will display a front-end Google error. So just make sure that health check route, the / or whatever you use, is valid. Okay. So that's our backend service. Let's click create. Okay. So let's move on to host rules and path. Yeah, there's nothing fancy here. I don't think we even need to put any host rules in there. Yeah, we don't need to get that fancy. But we do need to configure the front end IP. So let's call this SSL tutorial front end. So this is where we are going to do our SSL magic. So what do we want the front end to handle inbound requests with? HTTPS. How are we going to manage the certificate? And by the way, 443 and HTTPS, same thing. Whereas HTTP is port 80. Good to keep that in mind. So to make this work, the front end IP cannot be ephemeral. Ephemeral means it's subject to change at any point. We want a static IP. So we're going to do create IP. We'll call it SSL tutorial static IP. And instead of uploading a certificate, we're going to do create new certificate. All right, so again, we're just giving it a name, SSL tutorial cert. And we're going to do Google managed, so it takes care of that. We still need to provide our domain name, the domain name that is going to be proxying requests into the server. Okay, so then we just put our domain in here. I'm going to do askmacgyver.com and select create. And then we're going to go to review and finalize. Everything looks good here to me. I'm going to go to create. And Google's going to put this whole thing together, hopefully. Okay. Let's take a look at this guy. All right, so the public-facing IP address is this guy here, and it supports 443. If you request 80, you're not going to get anything back, and that's the way I want it set up. So you need to make a request that gets proxied through the domain for this to resolve properly. So let's set that up here. So now we just need to set up our domain, and then we should be all set. So let's go over to Cloud DNS. And we're going to create a zone. Okay, so it gives us these records out of the box. These name server records are going to be what we use to point the domain to Google Cloud. But what we now need is, okay, so once it comes to the Google Cloud CDN, well, where do we proxy the request? Well, where we want to proxy inbound requests from here to here, we want to proxy this request to our load balancer, right? To our SSL tutorial load balancer. What is the endpoint that represents this load balancer? The public IP address. So I'm in my load balancer. I'm going to copy the public IP address. I'm going to go over to Cloud DNS, open the records that I just created, and I'm going to create an A record, alias name, so that these inbound requests get pointed to the right load balancer. This is that TTL I was talking about. Let's do 5 seconds just so it flushes quicker. Yeah, and that's how we're going to know to send the request to the load balancer that we set up. And then the load balancer knows to send it to the VM group, so on and so forth. So now all we need to set up is our domain. So what's interesting here is I already have this domain. Set up pointing to another website that's hosted actually on DigitalOcean. So if I run dig askmacgyver.com, so see, it knows the A records, right? And this is the final IP that that's my domain. That's my DigitalOcean IP address. But let's change that. Let's point it to Google. Okay, so I'm going to go over to my domain registrar. In this case, it's Namecheap. They really all function exactly the same, so it should be about the same steps to get it to work on whatever you're using. All right, so again, Namecheap is where I bought my domain, and since I'm keeping it here, this is where you set up those DNS records. So again, here's my domain. This is my domain name list. And I'm going to go over to manage. So currently, it's pointing to DigitalOcean name servers. Well, let's point it to our GCP name servers. And those are provided here. And I'm literally just going to copy and paste these in. The reason there's more than one is because if one goes down, it'll have some auxiliary servers to try. I'll put them all in there. Okay. I click the little checkbox. Look, DNS server update may take up to 48 hours to take effect. That's true. It could take some time for it to update. But let's see if we can't flush everything and get it working. So I just went to Ask MacGyver. Here's our issue. So the certificate is provisioning right now, and that's why it's not working. So let's give it a little bit of time. Okay, so I just waited like 30 minutes here, and now you can see the cert has switched from provisioning to active. So I'm thinking we're probably good to go. Let's go ahead and refresh. And there you have it. See the lock pad there? That means it's SSL. And this is the website we set up. Again, just an example. Could be an API, could be anything. And so that's how you set up Google managed SSL. Hopefully that answers any questions people have. If you still have questions, feel free to leave them in the comments. And that's all I got. Thanks.